Hi guys, I'm Ankit. In this video shows another problem on LeetCode. Generate parentheses. So given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So they're given a number and we have to generate the well-formed parentheses that are valid parentheses. What do you mean by well-formed parentheses? That means if n equal to 1 they have given, if n equal to 1, then 1 open, 1 close. So this is well-formed parentheses. If n equal to 2, there can be one open, one close, one open, one close. So two open, two close, and also it can be other way also like two open, then two close. So these are the two forms. If n equal to 3 is given, then what we can have? We can start with one open, close, open, close, open, close, then open, open, close, close, open, close. So for every open parenthesis, you should have a corresponding close parenthesis. That is what we call as well-formed parenthesis, and we have to generate that with the given number n pairs of parentheses we have to generate. So how do we generate? So let's take this case n equal to 3 only. Okay, so if we take the case n equal to 3, that means we can have how many open parentheses? 3 open parentheses. And how many close parentheses? 3 close parentheses. So if we can have 3 open and 3 close parentheses, then how do we generate the parentheses? So let's start. So initially we have the empty string. Okay, we have the empty string. So once you have this empty string, what you can have that? There are two options. Is there are only one option, like you can have only one open parenthesis. When the string is empty, can you have a closed parenthesis? No. The first should be open parenthesis, then only the closed parenthesis should come. So the only option what you have is having an open parenthesis. Okay. So once you have this open parenthesis, next with this open parenthesis given, you can have one more open parenthesis. Why? Because currently the number of open parentheses is 1. So let's initialize both to 0 now initially. 0, 0. So how many open parentheses you have here? 1. So with this one open parenthesis, it's less than the n. So you can have one more open parenthesis. That is one case. And since we have one open parenthesis, we can have one close parenthesis for this. Okay. Again, go to the next thing. So you have this. So you have here open, open. Here two possibilities you can have. Can you have open parentheses? Yes, because only two are there. You can have max 3 open parentheses. Can we have close parentheses? Yes, we can have close parentheses because two open parentheses have and close parenthesis 0, which is less than 2. So two options. One is open, open, open. Another is open, open, then close parenthesis. Then if you move to this number, can we have open parentheses? Yes, we can have because one open parenthesis we have and that is less than the 3. So we can have open parenthesis. But can we have close parenthesis? No, because in this case, close parenthesis is equal to open parenthesis. You can have close parenthesis only if it is less than open parenthesis. So if you have two open parentheses, then you can one close parenthesis. If you have only one open, one close, then you cannot have one close parenthesis because there will not be any corresponding open parenthesis before to this. So this is not valid. So one major observation what we have uh, seen is, so if open is less than n, then we can have open parenthesis. Open parenthesis is possible. And if close parenthesis is less than open, then we can have close parenthesis. Got it? So here open and close are equal. It is not less than the open. So here we cannot have close parenthesis, but we can have open parenthesis because only one open parenthesis is present, which is less than n. So we'll have one open parenthesis. So now again go to this. 3 open parentheses we have. Can we have extra more open parentheses? No. Max 3 we can have. Then the other option is having close parenthesis because as I said 0 is less than 3 here. So let's have a close parenthesis. Then if you go to this example, two open parentheses, so we can have one more. So let's have one more open parenthesis. Let me just write it properly. Open, open, close, open. And since number of open parentheses more than close parentheses, we can have close parentheses over here. So two open parentheses, one close parenthesis we have. If we can have one more close parenthesis so that both are equal. So open, open, close, close. If you go to this example, How many open parentheses? Two we have. We can have one more. So let's do that. And how many close parentheses we have? One, but open are two, which is less than open. So we can have one close parenthesis. Now come to this. How many open? Three open. So three are done max. But close we have only one. We can have one more close parenthesis. Then for this example, three open we have. So we are having the option only to add the close parenthesis. In this also, two open we have. We have one more option to choose. One open parenthesis. Can we have a close parenthesis for this? No, because open and close parenthesis number are equal. You cannot have one more close parenthesis because if you have, you will not find any corresponding open parenthesis before to that. Like this, if you have close here, you will not. For this, we have this close. For this, we have this close. But for this closed, we do not have any open parenthesis. This is not valid. Next, coming here, how many open? Three open, max done. But one close, so we can have one more close parenthesis. Okay. In this, two open, two close, so we can have open parenthesis only. So and finally, yeah, three open, two close. So last one is the close parenthesis. Here also three open, two close. Again, same thing, close parenthesis. Here also three open, two close. So have a close parenthesis. Here also three open, two close. So have a close parenthesis. Again, same thing, three open, two close, close parenthesis. So you could see the number of possible parenthesis combination. Is it equal 1 2 3 4 5? So 5 strings, which is what we have to return. 1 2 3 4 5. So this is the way you generate the parenthesis. So how do we generate? So initially, if you see, we'll initialize open close to 0 and we'll have a, so according to the question we have to return all the strings in a vector. So we'll have a vector string, vector of type string. So in case of Java, we'll be using array list. That's the difference because we don't know what is the length of the array in this case. So we cannot have a specified length of array. So we use array list. So let's name it as res and we'll have a empty string. So we will have a function called parenthesis. So in this we pass res an empty string, then one open, one close, and also the given number n. This is what we need to pass into the function. So this is the resultant vector or array list, and this is a string. The each string we get whatever here you have to append it into the resultant vector. And this is open, close, open, close. And what is this? This is the number of pairs you can form. And one more thing, what is the base case which we need to handle here? When will you stop running this function? So as in when open becomes equal to close equals to n, open equal to close equal to n, right? 3 open 3 close 3 open 3 close 3 open 3 close, which is equal to 3. When this condition becomes, you have to append this particular string whatever you get to res. So that is what we have to look here. So yeah, this is the case. So write the function. You have to check if open close equal to this case, open equal to close equal to n, then we have to do res dot pushback we use, or we use add in array list of the string s. Okay, let's say str. And yeah, so with this, once you have this, and one more thing, now you have the string, yes. So with this string, we have to add that to the resultant, right? Next condition will be, when will you add open parenthesis if open number of open is less than n? So you have to check if open is less than n, then you have to do the recursive call to the next function like this. So how do you do? Same again, parenthesis of res comma the string whatever you have plus open parenthesis you have to do. You cannot do modify s equal to s plus this because that will be affected to next recursive call, because if close is less than open, then you have to call a recursive call function with this also. So just in the function you just give string plus open parenthesis, then yeah, so after this open plus 1, open will be incremented because one open parenthesis you are using here, then close will be as it is, and n. Similarly, if close is less than open, then what you have to do, same resultant, string plus close parenthesis this time, then open will be same as such, and here having close parenthesis, so close plus 1 you do, then n. This is what we need to function recursively call. So this will help us in generating all the functions. Once you found like open, number of open equal to number of close equal to n, you just add that particular string to the resultant vector or array list. So we shall program this. So let's say a function, let the type be void, and let's say generate. So first it will have a vector string res resultant, then a string s, and int open, then int close, and int n. So these are the parameters. First we need to check if open equal to close and close equal to n. You can't give in one line open equal to close equal to n. You have to give this AND operation, and then only it will be okay. If that is the case, then res dot pushback of the given string. Yes, and we need to return. So after this, you have to check whether open is less than n. If that is the case, then you recursively call the function generate of what? Same res, but this case s plus open parenthesis, comma open plus 1, because one open parenthesis we have added, then n. Same thing you have to check for the close also. So in this case, if close is less than open, then res plus string we add a close parenthesis, and in this case close will be incremented to 1. Yeah. So next we shall call the same function here. So generate, let's create a vector string res, then generate res comma empty string will pass, initially open and close will be initialized to 0, and the n, then return the resultant vector. Yes. One second. Okay, so the major thing which I missed here is here you have to give the ampersand. Why? Because whatever we do the pushback into the resultant vector, that should be on the original resultant vector, right? Otherwise, each time it will create a copy of that and push back, it will not reflect over in here in the res. So that is the reason you have to give ampersand to make a reference to the original vector itself. So now we will run and check. Yeah, and for Java, I'll explain the logic. So here you create a array list as I said before, and we call the function. So function we have list string and input all these parameters. If they are equal, if they are not equal, whatever conditions, what same logic applies in the code Java also. So we shall submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.